Welcome to Endless Learning Training Series, the membrane-based desalination technology.
In this presentation we will study about what is control valve, how does a control valve regulate the flow of fluid in a system, basic components of a control valve. What is control valve? What is control valve? Control valves. A control valve is a device used to regulate the flow of fluids, such as liquids, gases, or slurries, by varying the size of the flow passage, which means that a valve which can be put in any position between open and close by remotely. Most of control valve are globe valve type, but other type also used like butterfly valve. Basic components of a control valve and their functions. Control valves typically consist of four main components: the valve body, which contains the passages for fluid flow and houses the moving parts; the actuator, which is responsible for moving the internal components of the valve to control the flow of fluid; the valve trim, including the plug, ball, or other elements that regulate the flow of fluid through the valve; the controller, which sends signals to the actuator based on input. Valve positioner. Valve positioner is a device which receives the output signal from a pneumatic controller, I/P, which move the control valve position demanded by the signal. There are three primary types of positioners: pneumatic valve positioner, electropneumatic EP valve positioner, digital valve positioner. Pneumatic valve positioners. Description: these positioners use pneumatic signals, air pressure, to control the valve actuator. Advantages: simple and robust design, reliable in hazardous environments as they don't require electrical components, good for use in remote locations where electrical power may not be available. Disadvantages: limited precision compared to digital positioners. Susceptible to issues with air supply quality. Electropneumatic I/P valve positioners. Description: these positioners convert an electrical control signal, typically 4 to 20 mA, into a pneumatic output to control the valve actuator. Advantages: combines the benefits of both electrical and pneumatic systems, provides better precision and control than purely pneumatic positioners. Compatible with modern control systems that use electrical signals. Disadvantages: requires both electrical and pneumatic supplies, more complex than purely pneumatic. Digital, smart, valve positioners. Description: these positioners use microprocessors to convert control signals and provide advanced control and diagnostics. Advantages: high precision and control accuracy, advanced diagnostics and feedback capabilities, remote configuration and monitoring, can store data on valve performance for predictive maintenance. Disadvantages: higher initial cost. Requires more sophisticated maintenance and troubleshooting. How does a control valve regulate the flow of fluid in a system? How does a control valve regulate the flow of fluid in a system? Control valves regulate fluid flow by adjusting the size of the flow passage. When the controller detects a change in process conditions, it sends a signal 4 to 20 mA to the actuator positioner, which adjusts the position of the valve trim. Valve positioner is a device which receives the output signal from a pneumatic controller, I/P, which move the control valve position demanded by the signal. The 4 to 20 mA signal from positioner is converted to 3 to 15 psi, which apply to the actuator, which adjusts the position of the valve trim.
Thank you for watching this video.